All right, this is the 2018 AP Calculus Practice Exam, multiple choice. We'll start with number 1, where we have f of x is equal to 4 over x plus 5x minus 1. And we want to know what is f prime of 2. So let's rewrite this as 4x to the minus 1 plus 5x minus 1. Then f prime of x is equal to minus 4x to the minus 2 plus 5. All right, so f prime of 2 is going to be minus 4. I'm going to move the x to the minus 2 down to the bottom, so that'd be 2 squared plus 5. So that's negative 1 plus 5, which is 4. And that would be option A. Number 2, we want to integrate 6e to the 3x dx. So if you want, we can bring that 6 out front, e to the 3x dx. You can do a u substitution here if you want, but I think you might be able to just do that one in your head. The antiderivative of e to the 3x would be 1/3 e to the 3x. Practice, just to make sure, take that derivative in your head. It'd be e to the 3x times 3, and if we have a 1/3 out front, that'd get us back to e to the 3x. If you want to go through the u substitution, that's fine. So that'll be 2e to the 3x plus c, and that is answer A. Okay, number 3, we've got a graph. I'm going to just do a quick sketch of that. 1, got a hole, and then to the right, and then up here at 3, we've got another hole, and a line that goes like that. So it says take the limit as x approaches 1. Of f of x. So a limit exists when from the left and from the right. Now this isn't the limit as x approaches 1 from the left or the limit of x approaches 1 from the right. If that were the case, you would have an answer here, but your fingers would not touch. There's a gap there, all right? So that limit does not exist. So that is answer D. So since it's not saying from the left to the right, it's just as it approaches 1, again, your fingers have to come together in order for a limit to exist. So I can definitely see a problem like this being on this shortened AP test that you'll be taking this year. All right, pause if you need to. Okay, number 4, we have f prime of x is equal to 3x squared plus 2x. F of 2 is equal to 3. What is f of 1? Well, we need to get back to the original equation. So this is a derivative. So we have dy dx. I'm going to rewrite f prime of x as dy dx is equal to 3x squared plus 2x. And then let's separate the variables. 3x squared plus 2x. We'll integrate both sides. So we have y is equal to x cubed plus x squared plus c. Now let's enter the original condition. So we'd have 3 is equal to 2 cubed plus 2 squared plus c. So that's 3 is equal to 8 plus 4 plus c. So negative 9 would be c. So our original equation for y is x cubed plus x squared minus 9. So what is y of 1? Just plug 1 in. 1 cubed plus 1 squared minus 9. That's negative 7. And that is answer B. All right. Okay, number 5, I'm going to go ahead and write this table out. So we have t and r of t. 0, 100, 5, 100, 10, 75, and 15, 55. Okay, so it says, okay, this is a table that people leave at a rate of a building, leave at a rate R of t. How many people left in the first 15 minutes? Okay, so we don't have the function, but we can get an estimate of how many people left by using a Riemann sum. And it says we want to use the right Riemann sum. So the base for all of these is 5. 0 to 5, 5 to 10, 10 to 15. The height, you're going to use the one at the right side of each rectangle. Okay, so you're going to use 100, 75, and 55 for the height. Okay, so rectangle 1, the area is a base of 5, a height of 100. Rectangle 2, the base is 5, and then the height is, for this rectangle here, 75, the right Riemann sum. And for rectangle 3, again a base of 5. The bases don't have to be the same, it just is in this case, and the height is 55. Right, so you got to do this math in your head. So we've got 500. 5 times 75 is 375. 5 times 55 is 275. So add all that up and you'll get 1150. So the answer is B. I would absolutely be shocked if you don't get something like this. You'll need to know how to do a left Riemann sum, a midpoint Riemann sum, where you would take the average of the two. So in this case, a midpoint, you'd have a height of 100 and a height of 175 divided by 2, and then height of 75 and 55 divided by 2, okay? So midpoint left, midpoint, and right. You got to know how to do all three of those. Okay, let's see if I can fit 6 on this whiteboard. So we have y is equal to x squared times e to the x minus 1. They just want to know the derivative, dy dx. Well, let me go ahead and distribute here. We've got x squared. Actually, I'll do that. Distribute right here. So we have x squared e to the x minus x squared. So the derivative of that is going to be actually it might have been easier to not even distribute, but that's okay. The first, x squared, times the derivative of the second, that's e to the x, plus the second, e to the x, times the derivative of the first, 2x. So that's 2x e to the x minus 2x. Okay, and that matches answer C. Man, if you get a test full of those, you are going to make a 5. Let me tell you. Okay, gonna erase. Number 7 says we have acceleration, a of t, minus 4 sine 2t. And then we have an initial condition for the velocity, v of 0 is equal to 7. And we want to know what is the position at time t. So it's saying get the position function. So this is kind of a little bit of a long problem. We've got to work backwards twice. So velocity function, we're going to integrate acceleration. So integrate minus 4 sine 2t. Well, you could do a u substitution, okay? So, but I'm gonna just try to do it in my head. So that's gonna be minus 4, that's out front, times minus cosine 2t, because the antiderivative sine is minus sine, and then I would need also a 1/2. All right, so let me go ahead and go through the u substitution here. We're not in a hurry. you'd probably want to try to do it without it. So let's let, so we've got minus 4 sine 2t. So u would be 2t. du is 2 dt. Half a do is dt. So I've got negative 4 times a half. That'd be negative 2 cosine u, sine u du. So that's going to be negative 2 times minus cosine u plus c. So that's going to be 2 cosine 2t plus c. So now we've got to use that initial condition. All right, that's v of t. We've got to use the initial condition to get c. So that initial condition is 7 is equal to 2 times the cosine of 0 plus c. The cosine of 0 is 1. So 7 is equal to 2 plus c. So 5 is equal to c. So we had to do all that work to get the velocity equation. It's going to be 2 cosine 2t plus 5. Now we have to get the position. So we have to integrate that. We have to integrate v of t. I'm going to go ahead and bring that 2 out front. So it's going to be cosine 2t. We'll integrate them separate. Dt plus 5 dt. Okay, so that's going to be 2 times, going through the u substitution, you get 1/2 sine 2t. You can check that out. Plus 5t plus c. All right, so that's 2 times a half would be sine 2t plus 5t plus c. But it says our initial position is 0. So s of t is equal to sine 2t plus 5t, which is option A. So it's good that you had a bunch of short problems before this, because this one would take a while. But it's one you can do, and you don't want to skip anything that you can do. All right, I'm going to erase this. Number 8 is reading the graph of a second derivative. All right, let me draw that thing out. So this is f double prime. So we don't get the opportunity to read these too much. That's a terrible graph, but you can look at the paper. All right, so what's it saying? When f double prime is greater than 0, second derivative is greater than 0, it means it's concave up. And when the second derivative is less than 0, it's concave down. Okay, so we need to look at the 4 options of the graphs and see where we're concave up to this point on the graph, concave down from here to here, and then concave up. So concave up, and all of this portion is concave down. All right, looking at that, the only one that matches is D. So take a look at that, study on that just a little bit, and see if you understand that. Does that make sense to you? But I absolutely think this is the kind of question that could be asked. Number 9. Okay, when it has, this is the definition of the derivative, the beginning of chapter 2. And what they're trying to figure out is, do you remember the definition of the derivative so that you can look at something like this and see what the function is? The function, always just look at the part that's subtracted. So f of x is just the natural log of x. Okay, so that is the function. All right, it says that what is the derivative of f of x? Because all of this is just the definition of the derivative. So f prime of x is 1 over x. So at 2e, f prime of 2e is 1 over 2e, and that is option A. Okay, let's take a look at number 10. All right, dy dx is x to the fourth minus 2x cubed plus 3x minus 1. And they're asking for the third derivative. Okay, well, we got to take the second derivative to get to there. All right, so that's going to be f prime of x. Okay, we got to take the first. That is the first. Dy dx is the first derivative, so we need to get the second derivative. That's 4x cubed minus 6x squared plus 3. And so that's, excuse me, f double prime of x, because this is the first derivative. And then f triple prime of x is 12x squared minus 12x. So what is f triple prime of 2? Well, that's 12 times 2 squared minus 12 times 2. So 48 minus 24 is 24. And that is B. Okay, you could totally do that. All right, number 11. Number 11 is a little bit different. Okay, so it says that f of x is equal to, we've got x squared when x is less than 0, negative 1 if x is equal to 0, and x for when x is greater than 0. What is, if we go from negative 1 to 1 of f of x? Okay, so it makes it easy that it's just negative 1 when x is equal to 0. So that's just a point, and there's no area under that particular curve. All right, if you were to graph this, when x is less than 0, it's going to be a parabola. Okay, and then when x is greater than 0, it's just a line. All right, so when x is 0, it's negative 1. So to evaluate that integral, we really don't have to worry about the middle section. So you can rewrite negative 1 to 1 of f of x dx as negative 1 to 0 plus 0 to 1. Okay, that'll give you the whole thing. Okay, so for negative 1 to 0, our function is x squared. So that's 1/3 x cubed, evaluated from negative 1 to 0. And if you plug 0 in, it's going to be 0 minus, and then that would be negative 1/3. So that's positive 1/3 for that part. And then I hope you can read this part down at the, let me go ahead and just erase number 10 real quick here, and I'll go up to the top of the board. And then from 0 to 1, the function is just x. So that's going to be 1/2 x squared, 0 to 1. So that would be 1/2 times 1 squared minus 0, so that's 1/2. So the whole thing, negative 1 to 1 of f of x dx, is going to be what we had before, 1/3 plus this guy, 1/2. All right, and if you do the common denominator thing and all that, that adds up to 5/6 which is A. Okay, number 11. I think it's really understandable. Study that one a little bit. I can see you getting one like that. Okay, I'm going to erase. Let's look at number 12. I think I'll go through number 14 on this video. That's half the multiple choice. So we have 3x minus tangent y is equal to 4. We want to know dy dx. All right, in terms of y. So let's d dx that thing. So that's 3 minus, what's the derivative of tangent? It would be secant squared y dy dx is equal to 0. All right, so that's going to be that's going to be 3 is equal to secant squared y dy dx. Solving for dy dx, you'd have 3 over secant squared y is equal to dy dx. And what is something over secant squared? That's going to be cosine squared. So that's going to be 3 cosine squared y is equal to dy dx. And that is answer B. You could do that. We did problems like that. Okay, let's move on. Do a couple more in this video. Number 13. Okay, so for time t is greater than 1, the position of a particle moving along the x-axis is given as p of t is equal to root t minus 2. At what time t in the interval 1 to 16 is the instantaneous velocity equal to the average velocity? Okay. Well, let's get the average velocity. All right, so the average velocity is the slope of the secant line. Okay, so that's going to be p of 16. Again, we're going from 1 to 16. Minus p of 1 over 16 minus 1. So that's going to be, when you plug 16 in, right, 16, that's going to be 4 minus 2 is 2. And then minus negative 1. So we're plugging into p of t over 15. All right, so that's 3 over 15, which is 1/5. So we want to know, when does the instantaneous velocity equal the average velocity? Well, how would you get instantaneous velocity? Well, v of t is equal to, you take the derivative of the position. Well, the position is t to the 1/2 minus 2, right? So the derivative of that would be 1/2 t, so excuse me, minus 2. 1/2 t to the minus 1/2. And then the derivative of 2 is 0. So that'll be 1 over 2 root t. So when does that equal 1/5? This gives us the instantaneous velocity, p prime of t. When does that equal the average velocity, which is 1/5? Okay, well, I'm going to cross multiply here. So I'd have 5 is equal to 2 root t. 5/2 is equal to root t. Let's square both sides. We'd have 25 over 4 is equal to t. And I hope that's a possibility C. Yay! Got it. Okay, so that's 13. A little bit harder, but one worth studying. Maybe you marked that one. Okay, let's look over that. But I can see him asking that. That one's not so bad. Okay, the last one of this video. I wonder if you guys can hear all the weed eating and stuff going on outside. Y is equal to sine of f of x squared. This is one you're going to want to study. It's a little bit different. So what is dy dx when x is equal to 3? So we have a function inside there. Okay, so this is how you take the derivative of that. Y prime, what's the derivative of sine? It's cosine. So cosine of the blob. All of this is the blob. F of x squared. Times f prime of x squared. Okay, the derivative of the blob is, here, let's do it like that. The derivative of the blob, f of x squared, is just f prime of x squared. Times the innermost blob, the derivative of that, 2x. So I would have 2x cosine f of x squared times f prime of x squared. We want to know, let's plug in 3 for x. Plug in 3. So that's going to be 2 times 3 times the cosine of f of 9, right? 3 squared is 9, times f prime of 9. Okay, so that's, of course, 2 times 3 is 6. So let's look, let's look at answer D. D matches that. Okay, so you've got a 6 out front, and then an f prime of 9, and then a cosine of f of 9. All right, that'll do it for this video. We'll do the other half of the 2018 multiple choice on the next video, and happy studying.